Hi, I'm Paul Battaglia, and this is section 13.3, Modeling Data. You know, I have Gabe and Brittany here with me today, and they're here to tell us a little bit about how to structure a lesson and also how to help put our students at ease, because I know, Gabe, certainly that my students see all these formulas and symbols and they just get completely overwhelmed. So, you know, what do you tell your students in those cases?
Sure. So throughout the first two sections of this chapter, there's plenty of formulas and new symbols and new ideas that keep coming up.
Right.
And really what I like to focus on is not so much the formulas that happen. So I like to have them more focus on how to interpret them.
Okay.
So instead of calculating the correlation coefficient, I really like to focus on, well, how do we interpret the correlation coefficient?
So no memorizing then or anything like that?
Yeah, I like to show them the formulas, maybe go through an example at the board, but let them know that they won't have to memorize it for the exams.
Right, things like that. And I think that's important, and it's a personal preference, but I think, you know, we've all talked about it here. I just think it's much more important from our perspective that they're interpreting what these things mean, you know?
Exactly.
So speaking of correlation coefficient, Brittany, talk to us a little bit about, not the idea of correlation coefficient, but I know that when I'll see my students with their calculators, and sometimes they're programmed to just put the correlation coefficient, or it comes right up. So we might be dealing with some quadratic data or some exponential data, and they'll look at it and say, oh, the correlation coefficient is 0.97. Talk to us a little bit about that.
So I stress to my students that the correlation coefficient can only be used for a linear model.
Right.
And then what I also stress is how do we interpret it?
Right.
So we look at the strength and the direction.
Okay.
So the strength being closer to 1 or closer to -1, you know, is stronger correlation than being closer to 0.
Okay.
That's very weak correlation.
Okay.
And then also looking at the sign. So if it's negative, it's negative. You know, negative correlation.
What does that mean about the variables? You know,
so as one increases, the other variable will decrease when it's negative, and then when it's positive correlation, then as one variable increases, the other variable increases.
And you know, you actually, as you hear Brittany talk about that, you might even say to yourself, I feel like we've covered this before, and what this is going to seem very familiar, or what's going to seem very familiar to you, is the idea of direct and inverse variation. So it's kind of the same idea. It's not, but I think that's probably why you're thinking that. So Gabe, talk to us a little bit about an activity that you like to do with your students in terms of modeling this data.
Sure. So after talking about this correlation coefficient, we like to go into talking about least squares regression lines.
Okay.
So just a quick activity that I like to do with students is maybe pass out a worksheet where I have just a Cartesian plane with some data points plotted on it. And I like the students just to practice drawing the equation of the line which may best represent the data.
Okay.
So this idea here sort of gets them used to seeing, well, there's plenty of lines that you can use to represent the data.
Right.
But then from there we have a conversation about, well, there's only one best fit line, and that ends up being this least squares regression line.
Right, and I think it's great if you have 20 students in your class, you have 20 different lines. So I mean, that's perfect, you know? So I think that the thing to end with here, Brittany, is if I'm a teacher, and maybe I haven't taught this material before, or maybe just very briefly in the past, or if I'm a student, right? I think one of the big questions that you're going to get is, what is least squares regression, right? So how would you just kind of like simplify that for them?
So as Gabe was kind of saying, the best fit model is the least squares regression.
Perfect. Line. Nice and simple. Keep it standard for your students.
It might not be perfect,
but
it's the best we can do with real life data.
Exactly. I hope these tips have been helpful for you, and that you find much success in section 13.3.